Hello, this is Ms. Pat from San Public Library. This week in Science Scouts, we're going to be learning about the sun's energy for heat and light, primarily heat. We're going to be making a solar oven. And we're going to learn how heat gets transferred. Our story this week is called Happy Dog Sizzles by Lisa Grubb. It was a hot summer day. The blazing sun made everyone want to hide inside. Happy Dog and Jack Cat were bored. There must be something we can do to cool off, said Happy Dog. Let's go to the pool, said Jack Cat. Maybe we can go swimming. So Happy Dog and Jack Cat went to the pool, but the pool was too crowded. We'll never get cool at this rate, said Happy Dog. Just then they saw Captain Corky Puff putting up a big sign. What does it say? Asked Happy Dog. It says there will be a contest for the best wallaby, answered Jack Cat. That sounds like fun, said Happy Dog. There was only one problem. Neither of them knew what a wallaby was. A wallaby was anything you made from your imagination, Captain Corky Puff told them. My junkyard gives out a blue ribbon to the best one. Come along and see if you can build something. But remember, it needs to be special. So they went to the junkyard with Captain Corky Puff. You kids have fun, he said when they arrived. I can't wait to win the contest, said Jack Cat. They looked around at the piles of junk. Here's a lamp that looks like a fish and an old garden hose, said Jack Cat. I see an old tuba and a broken hat, said Happy Dog. Just think what great things we can build. So they built their first wallaby, but when they were finished, no one knew what it was they had built. Said Happy Dog. It looks special, but what can it do? We'll have to do better than this if we want to win that contest. Let's look for more junk. So they did, but their new wallaby was no better than their first. We need to think, said Happy Dog. All our pieces of junk need to fit together like pieces of a puzzle. The only question is, what should our puzzle look like in the end? So they sat and thought. When that didn't work, they walked around and thought. When that didn't work, they danced around and thought. It's too hot to think this hard, said Jack Cat. I wish we had something to cool us off. That's it, said Happy Dog. Let's build something to cool us off. That's what our puzzle will be. Why don't we just hook up the old garden hose and spray each other, asked Jack Cat. Because that wouldn't be a very special wallaby, answered Happy Dog. We want to win the contest, remember? So they collected more junk, only this time they knew what to look for. Happy Dog found a broken drum, and Jack Cat found an old suit of armor. Then Happy Dog took the tuba that he had found earlier, and Jack Cat brought over the fish lamp. Now watch this, said Happy Dog, attaching the garden hose to the spigot. What do you think they're going to make? It was the most wonderful sprinkler ever. We did it, said Happy Dog. We built a great wallaby. We'll win that contest for sure. Who cares about the contest, said Jack Cat as he ran through the water. I'd say we already won. Bye. Okay, so using recycling, right? They took a lot of old junk and they turned it into something to help cool them off. Well, we're going to use some things and we're going to use it to cook food, right? Let's find out how though.
So we're going to talk about how heat energy is transferred, right, or moved. All right, conduction is when heat energy is transferred by touching. You have to touch something, and then the heat goes from that thing to your hand. Could be like something metal, like a metal pot. Okay, you touch the metal pot, or you touch the burner that's on your stove, and it's going to burn you. That's conduction. Convection, though, is when it's moving a whole lot of molecules at one time. Usually it's hot air goes up, cools off, comes back down. Hot air warms up, goes up, cools off, comes back down. Same thing with water. So this water is being heated at the bottom, and it goes up to the top, and it cools off, and it sinks back down. That's how we get boiling water. That's convection. Okay, so hot air that goes up and comes down is convection. Water that heats up and goes back down, cools off, is convection. It is still boiling water, even when you touch the top. Okay, remember, it's hot water that came up. It's just a little bit cooler than the water at the bottom, but it's still going to burn you, so don't put your hand in that. Radiation is energy that's transferred by electromagnetic. It could be the heat coming off of a fire. You don't have to touch the fire to feel the heat. Just like you don't have to touch the sun to feel the heat. And sometimes lately, when you go outside and you look at the top of the car, you can see you can actually see the air kind of vibrating, just like these little squiggly lines here. And that's the heat coming off of the sun, coming off of the car from the sun. Okay, so that's radiation. Wouldn't want to sit on that car, right? Especially if it's a metal car. You don't want to sit on that with shorts because it's absorbed the heat. That would be conduction. Once you touch it, it's conduction. But if you just hold your hand above that car, you can feel that heat, and that's radiation. Metal is a very good conductor. Okay, metal heats up, it transfers the heat to whatever it touches. Be careful, don't touch a metal spoon that you've put in boiling water. Even a metal spoon in a cup of hot coffee, that metal spoon is going to get hot. Okay, if you leave it in a pot of boiling water, it's going to get hot. Wooden spoons don't. Wood and plastic do not conduct the heat as much. Okay, radiation is thermal energy that's traveling through the air. Remember, conduction, you have to touch it. Radiation, though, you can feel the heat through the air. And that could be from the sun, or it could be from a fire. Now, did you guys notice that when you go outside, sometimes what you're wearing might make you hotter? Maybe you and your friend are both outside, and one of you is wearing a black t-shirt, and one of you is wearing a white t-shirt, and one of you is hotter than the other one. Okay, when a color absorbs the light, it turns that light into heat energy, thermal energy. Okay, the more light the color absorbs, the more energy it produces. Black surfaces, okay, like the black street, absorbs most of the colors and the light from the sun. Therefore, it gets hotter than a white surface, which would be your white sidewalk. That doesn't mean sidewalks don't get hot. They just don't absorb as much heat. Okay, so we're going to be talking about black and white surfaces when we do our solar oven as well. Okay, but you might notice this next time. Or put out a t-shirt. Okay, put out a black t-shirt and a white t-shirt. Just put them out in the sun and then go out in about 30 minutes and touch them. Which one is hotter? One has absorbed all the colors and all the heat. The other one has reflected it. All right, so this is a solar cooker that they made from a pizza box. Heat from the sun comes into the box. It heats up this pan at the bottom. The metal pan heats the food inside. There are two types of heat transfer in this picture. Can you tell what they are? Remember, our choices are conduction, convection, radiation. So I'll give you a hint. One comes from the sun, just like fire. Okay, so that would be the radiation. And the second one transfers from the metal pan to the food, because the food is touching the metal pan, so that's going to be conduction. Now, if you guys get a pizza box, okay, because we're not going to provide those, but if you get a pizza box, you can cut a hole in it, prop it up like this, put tin foil on this top part, put black paper on the bottom, put your food there, And then cover that part with saran wrap so that the flies don't get in, okay? Because you don't want flies and food, flies and bugs and stuff on your food. So but you can set up an experiment. You can use any type of box. You can do this with a shoe box. You can do this with a cereal box. You just got to cut that flap, put tinfoil on the flap, okay, and prop it up. You can put black paper on the bottom, or you can put white paper, or you could put black on one side and white on the other side. Regardless, you put tinfoil on the top, cover it up with plastic wrap, and figure out which color cooks faster. Okay? Have a contest to see which one cooks faster. Scientists do experiments all the time. This is how they know that the black is going to cook usually faster than the white. But let's see, if you have the black in the sun, in the shade, it's not going to cook so fast, is it? Maybe the white will cook faster. So you can kind of play with that, right? And you can feel a temperature difference between the black and the white paper. Right? So we are going to get our supplies and we're going to set up our own solar cooker. Okay, so give me one sec. Okay, so we are back. Hi. I have my granddaughter Aurora here to help out this time. If you guys come into the library, you will get a science kit. Yes, it does have food. Try not to eat the food until you do the experiment, okay? So you're going to get things like a piece of tin foil. Black paper? Black paper. You'll have white paper in yours as well, and you can decide which one you want to do. So unfold the tin foil. Okay, because we have one big piece of tin foil for you. You won't necessarily be folding it on lines. We just kind of folded it up so it would fit inside the baggie. All right, and then I'm going to let Aurora explain. I know you can't really see on the paper that one side is dull.
Okay.
Right.
So we're going to be folding. We're going to have the dull side on the inside and the shinier side on the outside, so it will reflect the sun into the
S'more.
The s'more.
So put the shiny side down, and I'm gonna.
We take the scissors. We're going to fold.
So she's folded about three fingers worth, okay? 3 fingers worth. She folded it on the side, because that'll be the side of our box. And then she is going to cut. Now, don't cut on the fold. You're going to cut next to it.
This much.
Right up to here. Okay, so you're going to cut next to where you folded, and about the length of the scissor, big scissor. And you're going to do that on both sides. And then you're going to turn it around and do it on that side. Okay. So I just want to show you. Okay, this is where you guys folded. And then she cut right there. Okay, and she did that on both sides. Now we're doing this without a box, but if you guys want, the directions for the box have already been shown.
So now you'll fold it take like this. Take one flap and fold it up like this, like it's a little wall. Take the other flap and do the same thing over it. And then with the middle flap right here, you fold it over to make to keep them together. And then you do it again with the other side.
And the good thing about tinfoil is you can kind of shape it.
Fold over, and then you can shape it.
And now we kind of have a box. Okay, it's made out of tin foil, so the sun is going to come in, and hopefully it's going to conduct it. But just in case, we're also going, remember we gave you the paper, so you can do black or white. Remember, if you want, you could do black on one side and white on the other. Now this one is a little bit big, so you might want to cut a little bit of this off to make this a little bit, so it'll fit inside of there. Okay. Then you're going to take the stuff that's inside
The food.
You're going to take the food.
So you put your graham cracker down, and this time, I know some of you usually put the chocolate on then the marshmallow, but this time put the marshmallow on then the chocolate.
Okay, and the reason we're doing that, remember we said white is going to reflect it, so we want the chocolate to stay. Now, you might have to, all right, she's trying to squish it a little bit so it'll stay on top.
Okay.
Okay, because she's put it sideways. All right, doesn't matter if you want to squish it a little bit, that's fine, but put the chocolate on top, because remember we said the sun is going to be absorbed by the darker color, so we want the chocolate to absorb the heat, not the marshmallow to reflect it. Now, keep the other one inside, right, in a safe spot, and if you want, you can take the bag and you can tape that on top as your plastic wrap. Okay, yes, the bugs can still get in here depending on how big you made your thing. If you have a piece of plastic wrap, okay, at home, you can take plastic wrap and you can cover the whole thing. Then go outside and put it in the sun. All right, now, we just knocked ours over, so make sure before you leave it outside that it is set up.
Right.
You might not want to put the plastic wrap on until you get it outside, so it's in one spot, because trying to move it, it's going to fall apart. Okay, but we want you guys to see that this is how we have it. Okay, now again, it's falling off. So we're going to take this outside and we will be back. Okay. Okay, we had out there in the sun for about 30 minutes. Hasn't completely melted. Oops, but it is no longer rolling around. So I'm going to take it out of here and just kind of show you. All right. So the chocolate is definitely melted. You can see it dripping down the sides. The words are kind of going away. All you would have to do then is take your other half, even though this one is kind of cooked, because in the bottom of this graham cracker is very warm because the bottom of the black paper was warm. Take the other one, put it on top.
And now it's time for the best part.
And then you have the best part. All right, enjoy. Don't make a mess. All right, have fun. Thanks for coming.